Prudent Scholars in association with Goa Headmasters Association.
A shooter fires 5 shots at the target, out of which 3 shots hit the target. What is the probability that he hits the target? Case 2. What is the probability that he do not hit the target? It's an easy problem, and I can say you can quickly solve this. Let's try. I'll say, let A be an event that he hits the target. And we can see 3 shots at the target. That means probability that he hits the target is 3 out of total number of shots he takes, that is 5. Now I want the probability that he does not hit the target. So I'll call it not A. Let A bar be an event that he does not hit the target. In other words, probability not A. That will be, now look at the picture. In the picture you can see only 3 shots are hit at the target. What about the 2 shots? Those 2 shots give us a probability that he does not hit the target, and the probability is 2 upon 5. I'm going to use the same example to arrive to a new concept or a statement. I'll add the 2 probabilities, probability that he hits the target and probability the shooter doesn't hit the target. That is, probability that the shooter hits the target is 3 upon 5. He doesn't hit the target is 2 upon 5. Since the denominator is same, we add the numerators and write the denominator once. That gives us 5 upon 5, that is 1. In other words, probability that the shooter hits the target plus probability the shooter doesn't hit the target is equal to 1. We can also say that probability that an event happens plus probability event doesn't happen is equal to 1. That gives us rise to a new statement, that is, for any event E, probability of E plus probability of E bar equals to 1, where E bar stands for not E. E and not E are called complementary events. We can simplify this while solving the problems. We can make use of this formula, that is, probability not E equals to 1 minus probability of E, or probability of E equals to 1 minus probability of not E. Let's try this example. If P of E is 0.05, what is the probability of not E? And I want you to try this as quickly as possible. Options are A 0.95, B 0.095, C 9.05, D 9.5. Come on, try fast. It's a very easy, simple problem. We know that probability of an event plus probability of not E equals to 1. Also, we can write that same statement in this manner. Probability of not E equals to 1 minus probability of E. So probability of not E equals to 1 minus probability of E. That is 1 minus 0.05. We'll calculate this and the result is 0.95. And I hope that many of you got this answer. And the option is A. Good, well done. Let's move on to the next. Try this one. The probability that it will rain tomorrow is 0.85. Therefore, it will not rain is dash. The options are A. 1.85, B. 1.15, C. 0.18 and D. 0.15. Come on, try fast. It's easy. Come on. We know that probability of an event E plus probability of an event not E equals to 1. We can write this as probability of not E equals to 1 minus probability of E. That means probability it will not rain equals to 1 minus probability it will rain. That is 1 minus 0.85, and let's calculate this. And the answer is 0.15. And the correct option is D. You people are doing an excellent work, really. Let's move on. What is an impossible event? An event that cannot happen is called an impossible event. Let's take this example. What is the probability of sun setting in the east? Can anyone find the probability of sun setting in the east? Confused? We always know that the sun rises from the east. Can this event happen? Can the sun set in the east? No, you are right. It's an impossible event. Therefore, probability of an impossible event is 0. Remember this point. Probability of an impossible event is 0. Let's try this example. A die is thrown once. What is the probability of getting a number greater than 6? Now, what are the possible outcomes when a die is thrown? The possible outcomes are 1, 2, 3, 4, 5, 6. And we want the probability of getting a number greater than 6. Now, in the possible outcomes, can you see a number greater than 6? Can we see 7 there? Can we see 8 there? No. It's an impossible event. And probability of an impossible event is 0. Hope you understood the impossible event, and probability of an impossible event is 0. Let's move on to something new, that's sure event. What is a sure event? An event which is sure or certain to occur. Let's take this example. A game of chances consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, and these are equally likely outcomes. What is the probability that a pointer will point a number less than 7? Now, to find the probability that a pointer will point a number less than 7, we have to write the possible outcomes. And the possible outcomes are 1, 2, 3, 4, 5, 6. Let E be an event that the pointer points a number less than 7. The outcomes favorable to E are 1, 2, 3, 4, 5, 6. And we can see that all these numbers are less than 6. Then what will be the probability that the pointer will point a number less than 7? And it's going to be 6 upon 6, which is 1. That means probability of a sure event is 1. Let's try to understand this. The concept that I'm going to display on the screen. Probability of an impossible event is 0. Probability of a sure event is 1. Then what will be the probability of any event? Probability of any event will lie between 0 and 1. 0 and 1 are both inclusive. Now remember, the probability cannot be negative. It cannot be negative 0.5. Or probability can never be greater than 1. It cannot be 1.1. Or it cannot be 3 upon 2, which is 1.5. That means the probability has to be strictly between 0 and 1, and including both 0 and 1. Therefore, we can conclude that probability of an event E is a number P of E such that 0 less than equals to P of E less than equal to 1. To understand this, let's take this example. Which of the following cannot be the probability of an event? Be focused. And I want the answer as fast as possible. Try out this. A, 1 upon 2, these are the options. B, 15%. C, negative 1.5. D, 0.7. Come on, try fast. And I know you finished this. Let me try this. Half is 0.5. That's between 0 and 1. So it's a valid probability. 15% can be written as 15 upon 100. That's 0.15. That is also a valid probability. 0.7 is also a valid probability as it lies between 0 and 1. And what about negative 1.5? It cannot be the probability of any event. And hence, the correct option is C. Hats off to you. You people have done it so quickly. Wow. And this leads us to the statement, probability can be expressed in 3 ways. 1, as a proper fraction. 2, as a decimal. 3, as a percentage. Wow! You must be hungry. Right, I kept you some fruits. Let's try a problem based on these fruits. A fruit basket contains 11 bananas, 4 apples, and 3 mangoes. A fruit is picked up at random. What is the probability that the fruit picked up? 1 is an apple, is not an apple. Try this problem. I'm waiting for your answers. Come on. We have 11 bananas, 4 apples, 3 mangoes. Total number of fruits is 18. The probability that the fruit picked up is an apple equals to 4 upon 18. And we can reduce this fraction by 2. 2 nines are 18. 2 twos are 4. You get 2 divided by 9. Probability that the fruit picked up is not an apple equals. Now, my dear students, check this out. Not an apple means bananas and mangoes. That means total of bananas and mangoes is 14. And the required probability is 14 divided by total number of fruits, that's 18. And we can divide this by a common factor 2. 2 nines are 18, 2 sevens are 14, 7 upon 9. Hope it's very clear and you enjoyed eating the fruits. Let's move on to the next example. Wow! 2 dice are thrown. 2 dice are thrown simultaneously. Find the probability that 1. Both the dice have the same number or getting doublets. Second, sum of 2 numbers on the top of both dice is 8. Let's try this. We'll write all the possible outcomes. And we have already learned at the beginning of this topic how to find the possible outcomes when 2 dice are thrown. The possible outcomes are all this, and finally 6, 6. Starts from 1, 1, ends at 6, 6. On each face of the die, there is a number. That means there are 6 faces for each die. 6 multiplied by 6 will give us total number of possible outcomes. Therefore, case 1, we want the probability that both the dice should have the same number or getting doublets. And you can see 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Then what will be the probability that both dice have the same number? The probability is going to be 6 out of 36. That will be 1 upon 6. Let's try to find the probability of the second case. That is the probability that a sum of 2 numbers on the top of both dice is 8. Now we have to search the outcome which gives sum as 8. We know that 1 plus 1 doesn't give us 8, or 1 plus 6 doesn't give us 8. So it has to be 2, 6, as 2 plus 6 is 8. Then 3, 5, 4, 4, 5, 3 and 6, 2. That means outcomes favorable to the second case are 5. That is, probability that the sum of two numbers on the top of both dice is 8 equals to 5 upon 36. Let's try one more example. A card is drawn from a deck of 52 cards. What is the probability that the drawn card is? Case 1, a spade card. Case 2 is a king or a queen. Now to find the probability that the drawn card is a spade, we have to know the number of spade cards that are there in the pack of cards. So how many spade cards are there in a pack of cards? Come on, answer fast. Yes, that's it, 13. So there are 13 spade cards in a pack of cards. Therefore, probability of drawing a spade card is 13 upon 52. And we can reduce this fraction by dividing by 13. 13 ones are, 13 fours are, we get 1 upon 4. In the second case, we want the probability that the drawn card is a king or a queen. So, number of kings and queens in a pack of cards is 8. That is 4 plus 4. That's equals to 8. So, probability of drawing a king or a queen equals 8 upon 50 dividing by 4. 4 2s are 8, 4 13s are 52. You get 2 upon 13. Hope you understood this example. Let's try one more. A lot of 20 bulbs contains 4 defective ones. One bulb is selected at random from the lot. What is the probability that this bulb is defective? Second, not defective. So altogether, there are 20 bulbs. So out of which 4 are defective. Therefore, probability that the bulb is defective equals to 4 defectives upon total number of bulbs, that's 20. And that gives the answer as 1 upon 5. That gives the answer as 1 upon 5. That is, probability that the bulb is defective equals to 1 upon 5. To find the probability of the second case, that is probability that the bulb is not defective, we have to find the number of good bulbs or not defective bulbs. So, number of not defective bulbs equals to 20 minus 4, you get 16. Therefore, probability that the bulb is not defective is 16 divided by 20 and you get 4 upon 5. Yes, my dear students, hope you understood this topic, probability, very clearly. And hope you enjoyed learning probability with me. Here's a summary of the entire topic, probability. The definition of probability. Probability is defined as P of E, that's number of outcomes favorable to E divided by number of all possible outcomes of the experiment. That's a definition. And let's understand the concepts that we did. The sum of probabilities of all elementary events of an experiment is 1. It's 1. Second, for any event E, P of E plus P of not E equals to 1, where E bar stands for not E. E and E bar are called complementary events. In other words, probability that event happens and probability that event doesn't happen, they are known as complementary events. Probability of an impossible event is 0. Probability of a sure event is 1. And probability of an event is a number P of E such that 0 less than equals to P of E less than equals to 1. Now I suppose it's very clear. And I don't think you're going to forget this topic called probability. Here's a worksheet for you in a form of evaluation. I want you to try all these problems. These are very, very important problems. These problems were asked for the earlier board papers. And I want you to try each and every problem so that you score full marks in probability and full marks in mathematics. Yes, my dear students, I enjoyed teaching mathematics to you and hope you enjoyed learning mathematics with me. Let this relationship continue so that you and I are successful in mathematics. I'll stop here. My dear students, stay home, stay safe, take care. Bye-bye. Thanks. Thanks a lot.